We have done up to the density.
Density reaction with air, that all we have done. Reaction with air also.
Reaction with air. Sir, we have done up to that one color test: melting point, density, reactivity,
Okay.
hydration, and
I taught you peroxide, superoxide, monoxide. These things I taught you. Now today I am going to second
lithium,
part.
sodium mono and peroxide. That one.
Yeah. Today we are going. This is the NCERT book only. The first one, reactivity towards the water. We are going to study the how it is reactivity water. See, these metal, if you talk about lithium, whether sodium, potassium, or rubidium, cesium, francium, they are very reactive metal. Getting my point? And since they are very
Yes.
reactive metal, what is going to happen? They catch, sometimes they catch the fire, like sodium, potassium, they catches fire and highly reactive. So in spite of putting in the water, we keep in the kerosene. So here you see the alkali metals react with water to form hydroxide and hydrogen gas liberated. So how it is the hydroxide is forming, although this hydroxide is forming, but this is the ionic in nature. This is metal, it can be this all metal, that is M, all the lithium, sodium, potassium, reacting with the water, it is forming M plus and OH minus. Why we are writing? Because this is in the water, in spite of MOH, this present in the form of ion. Okay, highly M plus OH minus. So this is mentioned in this form. If you are mentioning that is MOH, that is also not an issue. And hydrogen gas is liberated. Now, the second point you see, it may be noted that although the lithium has most negative inert value, highest, that is most negative inert value is which element? Lithium. And
Lithium.
highest value, which one is there? Fluorine. Fluorine. So lithium is, because it is the highly negative value, na? Highly negative value. So it is what is reducing agent. This is what reducing agent. Okay. And fluorine, if you talk about the E naught value of fluorine, if you talk about most positive. So most positive, so oxidizing agent. Oxidizing agent. So anything having the negative SRP value, E naught value, it will be the reducing nature. And positive value, it is going to be what? The oxidizing nature. So here you see, it is reaction with the water is less vigorous than that of sodium, which has the least negative E naught value among the alkali metal. This behavior of lithium is attributed to its small size and very high hydration enthalpy. Okay. Now the point here you need to understand, it may be noted that although lithium has most negative value, how much is there? Most negative value. Its reaction with water is less vigorous. Its reaction with water is not that much vigorous comparatively to sodium. Okay. Then that of sodium, which has the least negative, least negative value. Sodium is having least negative value among the alkali metal. What is the reason here? From the here you go the negative region. This behavior of lithium is attributed to its small size, very high hydration enthalpy. Other metal of the group explosively with water. Explosively means what? That is they catches the fire. But lithium do not catch the fire. Why it is not catching the fire? They are saying this is the reason. This behavior of lithium attributed to its small sizes there and very high hydration enthalpy there. So because of this one, it is not catching the fire, while other metal catches the fire. Here you see some other point. They also react with proton donors such as alcohol, gaseous ammonia, or alkynes. In spite of, suppose, if you're talking about sodium and treating with the water, HOH, this is okay, no problem. So it will forming what? The 2NaOH, ionic. This is the plus and minus. Along with that, what is the hydrogen gas is also liberated. They are saying they also react with proton donors, okay, such as alcohol, gaseous ammonia, and alkynes. Now, this reaction, what the word they are using in NCERT, they themselves are very important. Suppose if you are hydrocarbon, they started in your school.
Yes.
Hydrocarbon. This reaction you study in the 10th standard, if you remember this one. This is the alcohol. treating with the sodium metal. So what it was going to give? CH3, CH2, O, Na plus Na plus hydrogen gas is liberating. If you are taking two molecule, you need to take two molecules. This is the two molecule and their hydrogen gas. Yes or no?
Yes.
It is also reacting with the gaseous ammonia and alkyne. Alkyne I am dealing here. CH triple bond CH is there. See, this is the sp hybridization. Now, sp hybridization means 50% S character. So high electronegativity is there. So it will react with the electronegative atom, react with the sodium. So two sodium you react. So what it will give? Na plus. Here is C. Triple bond C. Here is Na plus. And what will give? Hydrogen gas. So it is also reacting with the alkyne. Ammonia, reaction with ammonia, that we will discuss in the heading separately. Let us firstly discuss with the ammonia. It react with ammonia and impart the color. Somewhere it will be there. Here you see. Solution in liquid ammonia. Solution in liquid ammonia. This is very important for the competitive track. What is happening, Sanoy, if you see, right? The alkali metals dissolve in liquid ammonia, giving deep blue solution, which are conducting in nature. Okay. Now here I need to find out the some blank page so that I can explain here. Is there any? No. Okay. See what is happening here. M you have taken. So M you are taking, no problem. So M is in the which form? If you are dissolving, it will form one M plus and one electron minus. Yes or no? Yes or no?
Sorry, plus and
M means it will give, suppose if you are taking sodium, what it will give? Na plus and one electron, yes or no?
yes.
Now, you are taking X plus Y molecule of NH3. You are taking how many molecule of NH3? You are taking X plus Y molecule, right? So now
Yes.
see how it is combining. One you combined with the NH3. Okay, one you combined with the NH3. Which one? X molecule. If you are splitting this one, so what you will find, that is M plus electron is there. And here in the solution, X NH3 is there. X NH3 plus Y NH3. This molecule are there. X NH3 plus Y NH3. These are the molecule. After multiplying, if you multiply this one X NH3, Y NH3. Now see, this one M plus and NH3. This one. So what the compound you are getting, that is MNH3. And you know, so NH3 is the neutral one, neutral ligand. So there will be positive charge, as like the metal, it is having positive charge here. Now, the electron is going to combine with what? YNH3, this one. So what will be there? E, another bracket we are applying, NH3, and this is how many time? Y time. And the negative charge is on the top. This is what the reaction. So this is how little bit elaborative way. M plus X plus Y NH3. So M NH3X, this is plus charge. E NH3Y minus charge. This electron is free electron. Free electron. Impart deep blue color. IMPART, impart deep blue color. Can you understand the equation?
Yes.
Sure or not?
Yes.
Okay. If you not, you let me know. The blue color of the solution is due to the ammoniated electron, which absorb the energy in the visible region of the light, and thus impart blue color to the solution. So here the electron is there now. If the electron is there, you see, this electron is there. One electron is there. So there are many higher energy orbits are also there now. So once it will absorb the energy, it will jump here. So electron reach here, but this electron cannot. This high energy electron is unstable. So this will fall again here, but loss energy, loss energy, loss. 10 बजे 9:30 loss energy. Loss energy in visible region, where you are losing in visible region, loss energy in visible region. So loss energy in visible region, what will be there, student? This is the color. Not able to understand, Sanoyji?
No, sir.
Why you are not able to understand? You study the Bohr's atomic model.
Yes.
Electron is there in the first orbit.
Yes, sir.
If it is absorbing the energy, where it will go? If it is absorbing energy, it will jump to high energy orbit. Yes or
Yes.
no? After that, it will be falling in the again the same position because 10 power
Yes.
minus 6 second it is jumping out. Then again it fall. When it is falling means the loss of energy will be there, na? Loss of energy.
Yes, sir.
This loss of energy in visible region, any energy in visible region, what is there? VIBGYOR. Yes or no? In visible region, this
Yes,
is the
sir.
spectrum. So some it will be what? In the visible region, it will give color or not?
Yes.
I don't know you are understanding or saying yes only.
Sir, now understand.
Okay, good, good, good. See, the solution are the paramagnetic and are strong, standing slowly liberated hydrogen resulting in the formation of amide. So what the problem they are saying? That is the solution will be because this electron is free, na, this electron. So the solution will be what? Paramagnetic because one unpaired electron is there. So solution is what they are saying? Paramagnetic. Now, another point. On standing, slowly liberate hydrogen resulting in the formation of amide. If it is the long time standing metal in the ammonia, what it will do? It will liberate the hydrogen gas and it will form the amide. So this is called, suppose one reaction is there, NaNH2. This is called amide. This will come in the hydrocarbon chapter, hydrocarbon. Uh, this is called amide or you can say sodamide. NaNH2 is called sodamide. Let me explain you. It will be helpful. Suppose here is the compound is there. Just I am giving you little bit information. Kindly keep in this. This is what is called vicinal dihalide. Vicinal. You must have studied. Vicinal dihalide. Why vicinal? Because two halogen are there, two consecutive carbon. You are treated with the KOH. KOH. Which KOH? Alcoholic. So it will give K plus plus OH minus. Right. So this OH minus, I am taking OH minus, attacking on this one. So this bond is shifting and this chlorine is out. So if chlorine is out, see. So this K and this Cl will be out. So what is going to out? This one H2O minus H2O and minus KCl. So here you see the compound, what is being formed? H, here is Cl, double bond C, this is H, here is H. Now you are treating with what? Sodamide, NaNH2. That is what is the, we studied just now. So this NaNH2, this sodium is will be out in the form of NaCl.
Yes, yes.
Now this NH2 and hydrogen will be out in the form of NH3. So what is left here? This hydrogen, carbon, double bond, carbon, hydrogen. Since you know the carbon valency is 4, so we have to place double. So this is the method of preparation of what? Ethyne. So
Yes.
this is what is called sodamide. How sodamide is forming is when it is the standing position. Long time if it is the, here you see paramagnetic on standing slowly liberate hydrogen resulting in the formation of amide. So this is MnH2. M means what? Sodium, potassium, rubidium. M. Is it okay?
Yes.
Now, in concentrated solution, the blue color changes to bronze color and become diamagnetic. If it is the very concentrated, in concentrated solution, if the solution is concentrated, the blue color changes to bronze color and become diamagnetic. So this question may ask, that is, if the dilute is there, paramagnetic. If the concentrated solution of ammonia is there, that will become the diamagnetic. And color will change deep blue to bronze color. Now, the next point. What is the usage of there? We are going to deal with the usage of the alkali metal. So they are having, have you heard about the sodium potassium pump in bio? Have you studied
Yes, sir.
sodium? Okay.
Yes,
All the nervous system work because of the ions only. Okay. Here you see,
yes,
lithium metal is used to make useful alloy. For example, with lead, make white metal. Okay. Nowadays, lithium battery is also being made. Next,
yes, sir. In electric vehicles.
Mhm. Bearing for the motor energy, engines, bearing of motor engines. This is also being used with aluminum to make the aircraft prop. If you are making the lithium and aluminum, okay, lithium and aluminum, they are making part of aircraft. With magnesium to make the armor plates. What is armor plates? That is bulletproof jacket is called armor plate. So if it is mixing with the magnesium, lithium and magnesium, it is making the armor plate. It is used in the thermonuclear reactions. Thermonuclear reaction. So nuclear reaction also being used. Next one. Lithium is also used to make the electrochemical cell. What is the electrochemical cell? This is
Without
battery.
battery.
Battery. Thank you. Sodium is used to make the NaPb alloy needed to make PbEt4 and PbMe4. These are the catalysts. Okay. Tetraethyl lead. Tetra. Et means ethyl, C2H5. This is what Et written. That is the C2H5. And Me means, what is Me means? Methyl, CH3. So what where it is being used, Tanvay? You can see sodium is used to make the NaPb alloy, needed to make the PbEtO4 and PbMe4. These are the, now see here what the point they are saying. These
Sir,
cannot,
sir, just one minute, sir. Sir, can you give me just 1 minute time, sir? I will go to the washroom.
okay, okay.